Hi there, Sci2 kiddos. Just a quick lesson about calculating the eccentricity of an ellipse and the circumference of a circle, which you're going to have to do for your orbit drawing activity. We're going to use a dot right here to represent a star, and we'll have planets orbiting around it. This could be a planet with moons orbiting around it as well. But we have elliptical orbits and circular orbits is what we've learned about. So for an elliptical orbit, the star is one focus, but there's another focus, and for the activity you're going to draw it a little bit below the star there. Now in space there's nothing there, it's just another center of gravity. The gravity's coming from the star entirely. But to draw an ellipse around that, you'll see in the activity how you do it, but an ellipse is essentially sort of a stretched out circle from that point. And so I'll draw it looking like this. Again, not perfect ellipse, but clearly not a circular orbit either. So the eccentricity is a measure of how circular your ellipse is. So eccentricity, and we calculate it as E equals C over A. And so the C value, the first thing you need to do is find the center, which in this case is the halfway point between the star and this gravitational point. So I'll draw that right there. That's the center of our ellipse. Not the center of our gravity, though. Remember, the star is the center of our gravity, but that's the center of the ellipse. The C value then, right here, is the distance from the center to one of the focus points. That's your C value. The A value, down here on the bottom, is a larger number. It's the distance from the center point to the outermost point of the ellipse. That's your A value. So you got to find that center point between the two foci, measure the distance from the center point to the outermost edge, and measure the distance from the center point to one of the focus points. Doesn't matter which one, they should be equidistant. And the point is that you're going to have a small number divided by a large number, which will give you something below 1, right? It'll give you 0 point something. Circles have an eccentricity of 0. Circles equal 0. And so the closer to 0, the rounder or the more circular the ellipse is. And less close to 0 means it is more elliptical. Okay. A circle is just evenly spaced from, again, you're drawing from your star point right there. And so I'll do my best to sort of draw just a wide circle here, encasing that. And for the circle, you're going to have to find what's called the circumference. And I'm sure a lot of you are familiar with this. Circumference is just calculated as 2 pi r. Pi is 3.14. R stands for radius, which is just the distance from the center point to any edge of the circle. That's your radius. So all you got to do is measure that. Do 2 pi r, and you've calculated the circumference. Notice that eccentricity will not have a unit on it because it's a ratio. So if you measured in centimeters or inches, it doesn't matter as long as they cancel out. There's no unit on eccentricity. But for circumference, you will have a unit. It's whatever you use to measure the radius. So if you measure it in centimeters, your circumference will be in centimeters. If you measure radius in inches, your circumference will be in inches. That's it.